Hello friends, welcome to follow up. Let's have a look at a newly appeared problem, problem 2641, cousins in binary tree 2. Actually, in order to warm up for analyzing this problem, we first finished problem 993, cousins in binary tree 1, right? So in this video, again, we're going to explain a solution based on traversal. Here we are given the root of a binary tree. We want to replace the values of each node in the tree with the sum of all its cousins' values. So here, two nodes of a binary tree are cousins if they have the same depth but with different parents. So we are required to return the root of the modified tree. So notice that the depth of a node is the number of edges in the path from the root to the node itself. For example, here the nodes with values 1, 10, and 7 are at depth 2, right? Because, for example, from the root 5 to node 1, they have 2 edges, right? So here we have two examples. Let's first look at example 2. So in example 2, we have a binary tree. The root is 3, and it has two children, 1, 2. So in this example, all the three nodes have no cousins. So therefore, their cousins value sum all are zeros. So actually, this is the values after reset, right? All the nodes change their value to be 0. So here 1 and 2 deserves some explanation, because they are brothers rather than cousins, because they have the same parent. So this is example 1. So if we look at example 2 after seeing example 1 after seeing example 2, so notice that the nodes with values 5, 4, 9 are changed to be 0, because all these three nodes actually have no cousins. So their values after reset will be 0. And in the level 2 or depth 2, so the two nodes 1 and 10 are brothers, and they are cousins of 7 and vice versa. So for example, in order to set the values for the node 1, so we need to set it to be the cousins value sum. That is 7, right? Same for 10, right? So we have 7, 7. And for the nodes with value 7, so their cousins, its cousins are 1 and 10. So the sum is 11. So we have 11 here. So this is the output, right? So here we explained how to interpret the output. However, if we want to do the problem, we are not using addition. Actually, we are using subtraction. And this point will be made clear in the coding. So let's look at the constraints. First, the number of nodes in the tree is in the closed interval 1 and to 10 to the power 5. So 10 to the power 5 is a decent large number. Secondly, the node values are in between 1 and 10 to the power 4. So I want to point out a difference of this problem with problem 993. So here in this problem, the nodes values are not unique, right? So though the examples in example 1 and example 2, the nodes values are distinct. So this is just for demonstration purpose, right? So in this problem itself, it's possible that the nodes have a same value. So with that said, let's look at the analysis. So in this problem, basically what we're going to do, I'm going to use traversal. So for this, basically we need to our task is to reset the values. So here the question is how to do the reset. So actually the thing we want to do, rather than using addition as we mentioned, we use subtraction. So this is a different direction of thinking this procedure. So if we want to use addition, for example, if we want to replace the value of 1, so we need to sum all the cousins values. So that computation actually can be huge. For example, after we set for 1, for 10, and we need to do the same thing for 7. So also another thing to worry about is that if we first reset the values of 1 and 10, then if we look at 7, so we cannot add the reset values, right? This is another point. So how to use subtraction? So basically, we want to use the level sum minus the brother's value sum. So what does it mean? For example, if we reset the values for 1, 10, 7 here. So in this example, the level sum at level 2 is 1 plus 10 plus 7, that is 18, right? Then in order to reset the node with value 1, so what do? So we use the sum, the level sum, minus the brothers sum. So here the brothers will be 1 and 10, right? Because these are not, because 10 and itself are not cousins, we need to subtract that. So what's left is the sum of the cousins value. So here we minus 1 minus 10, we're going to get 7. So this is the same for node 10, because due to this way or this rule, so the brothers will have the same value after reset. So now if we want to reset the value for node 7, what do? So actually we do 18 minus the brothers sum. So here for the node 9, it has only 7 itself as a child. We just minus 7, that is 11, right? So this is the procedure. Another thing to notice, so this is the point 1. Another point to notice is that for a node, during traversal, we set its children's values. So this way, we actually implicitly using the parent and the children relations, right? So when we traverse a node, so we check their children's, then we just reset their children's value. So the plan for the coding is the following. So we are going to first retrieve the level sums. So basically we want to, for each level, for example, level 0 here, the sum is 5, level 1, the sum is 13, and level 2, the sum is 18, right? So then after we find the level sums, so we can do the resetting, resetting. So this is our plan. For this, actually we can use 2 passes of traversal. So I'm going to do this. First, I'm going to write a utility function to get level sums. So once we get level sums, and then do the resetting is a breeze. First, let's do this. So let's see. We write here. I'm going to write get level sums. So it accepts a node. Let's call it root. So then what we want to get actually is level and level sums, right? For this, actually we can use level order traversal. So first I'm going to use a container to get the current level, right? So this is just the root itself, and then the current level is 0, right? And then that will be the standard while loop. So while the current container is not empty, first I want to get the level sum, that is the sum. Here I'm using comprehension. So we're going to have node value for node in this container. So after we get this level sum, so we're going to set the level to be the level sum, right? So this level and level sum is a key value pair. So after we do this, so we're going to update the container and update the level. So the level is incremented by 1, and the container is updated again by list comprehension. So here, child for node in C, for child in, so let's use a tuple, node left, node right. We need to filter out the nulls, so if child. So notice that here the node left and node right order is not important, because our purpose is to compute the level sum, and summation or addition is commutative, right? So with that done, basically we are done. So we return and this D, right? So after we write this utility function, so actually we can just write directly call this and do a traversal to get this thing. We write this utility function to isolate the ideas into smaller pieces to make the logic clear. So let's first get level sums. So let's call this, let's just copy this part. That will be much safe to avoid typing errors. So now next step will be reset. So for this, actually, we need to do another traversal. Here I'm going to do based on maybe pre-order traversal. So you can see here I would see depth search based, so that I don't need to care about the order. So as long as we finish the traversal, things will be done. So I'm going to have a root and 0. So here what we are going to store is node as a level, right? We need to know the current node's level so that we can reset its children's value, right? So with that said, basically corresponding to the above, so standard while loop. So here, while s is not empty, we're going to get the node and the level. So it's going to be s pop, right? And then what we want to do first is to check if the values. So here, let's see, not check the values. We want to first get the children value sum. So for this, actually, what we are going to do is let's first initialize children value sum to be 0. So for now, we do not know how many children does this node have, but we just need to check. So here, if node left, so we're going to increment this one by the corresponding node value. Node left value. So similarly, let's copy this one, check the right child. So actually here the order is not important, because again we're going to compute the sum, right? The addition is commutative. So after this, let's do the reset, do reset, and do traversal. So basically we need to check the left child and the right child, then reset its value. So we can use this order, but you know, if we first check the right child then left child, it will correspond to pre-order traversal of a binary tree, right? So here, in order to fun into that, I'm going to check right, if node right. So what we're going to do first, let's set the value, right? So we're going to set node right value to be level sums. So this is a dictionary, right? So the current level for the node right actually is level plus 1. Then we want to minus this children value sum. In other words, the sums of the possible brothers, right? So here, don't forget to append the corresponding information to the stack. So here, as append. So node right, and the level. The level will be level plus 1. So here, actually, we are not very interested in the value of the node right. We are interested in the node itself and the corresponding level. so that we can continue the traversal, right? So next we're going to check node left. So here left. So here we need to check modify here left. So then the first line here and here is a reset, and the second line here and here is the traversal. So actually after this, basically we finished the bulk of the work. And also because we start setting the children value for a node, don't forget to set the root value. The root value should be 0 because the root has no cousins. So then we are ready to do the return. We return the modified tree. So with that done, basically this forms a solution format to this problem. So before we make comments, let's first do a check. It passes one example. Now let's look at this one. It passes another one. Now let's look at the generic case. It passes all the generic cases. So with that done, basically that's about it for this problem itself. So in this video, actually we address the problem by first retrieving the level values, node value sums, and then do the resetting. When we do the resetting, we first set the children values, and then we set the root values. And in between, so basically we did a level of the traversal, and then did basically this way of writing here corresponds to the pre-order traversal of binary tree. So because of the order here, node right and node left. So actually here, for this purpose, in this problem, the order here again is does not matter. So you can put left in front. So with that said, basically that's about it for this video. Thank you.